Welcome to the ninth lecture. We are studying stochastic processes, and for the last few lectures, we are studying Poisson process. Today, we'll continue with an example of a clinic where patients are received at a rate of 1/10 per minute. This means 1/10 per minute arrival rate means that the inter-arrival time between two successive patients is 10 minutes. Assuming number of patients received in time t is assumed to be a Poisson process. Number of patients received in an interval of time t is assumed to be given to be a Poisson process. In part A of the example, we are required to find average number of patients received in half an hour. Half an hour means in 30 minutes. We know we are being asked about the average of number of patients. Since number of patients received is distributed as Poisson random variable, so average would be the average of Poisson distribution for time t, and we know that for a Poisson process this is lambda times t, where lambda is the rate of arrival and t is the length of the interval. Here t is given to be 30 minutes and lambda is 1/10. So 1/10 times 30 gives us 3 patients. So the answer is that expected number of patients received in 30 minutes, half an hour, are 3. So lambda remains the same and we move to part B. Here we are required to find expected inter-arrival time between any two patients. So what is the expected inter-arrival time between two patients? We know that the inter-arrival time is modeled with, in our earlier lectures we have modeled inter-arrival time with a distribution. We call it exponential distribution, and in last lecture we have studied that the expected value of an exponential distribution is given to be 1/lambda. So the expected inter-arrival times between patient, suppose this is the time we receive patient 1, this is the time we receive patient 2, and these are inter-arrival intervals. So the average length of these intervals, they may be different, but the average length is 1/lambda, means 1/1/10. This means 10 minutes is the average of the inter-arrival time between two patients. And now let's move to the final part of the problem, part C, where we are asked, where something is given first and then we are asked. It is given that doctor at clinic starts examining patients after they are 3 in the queue. What is the probability of not examining a single patient in first 1 hour? So we want to know the probability that no patient is examined by the doctor in first 60 minutes. 1 hour means 60 minutes. This means we haven't received 3 patients in 60 minutes. That is why the doctor hasn't examined a single one. This means we have to find out the probability of receiving less than 3 patients in 60 minutes. If we receive less than 3 patients in first 60 minutes, doctor wouldn't examine even a single patient in first 1 hour or 60 minutes. So this probability is equivalent to receiving that number of patients received, PAT, patients received, is less than 3, strictly less than 3, not equal to 3, strictly less than 3 in 60 minutes. This means we can have x, if x is the variable showing number of patients received, x is equal to 0 in 60 minutes plus the probability of having 1 patient in 60 minutes plus the probability of having 2 patients in 60 minutes. In all these 3 cases, doctor will not examine even a single patient in first 60 minutes or first 1 hour. That no patient is received, or we have received 1 patient, or we have received 2 patients. The joint probability of these 3 events is 0. Therefore, we haven't subtracted that. Even the joint probability of any 2 events is also 0. So we can straight away add these probabilities together to get this probability of not examining a single patient in first 1 hour. So this is assumed to be Poisson distribution. So the probability of receiving no patients we are given to be that lambda is 1/10 and t is 60. So probability of having no patient, x is equal to 0. This is according to the PMF of a Poisson distribution minus lambda t 1/10 times 60 lambda t to the 0/0 factorial plus e to the minus 60/10 having 1 patient, 60/10, this is lambda t, lambda times t to the k, where k is 1 here, 1/1 factorial plus e to the minus 60/10, 60/10 raised to the 2 divided by 2 factorial. So if you add all these terms, it's left as a homework for students to calculate these using your calculator and add these 3 terms, and you will reach to this probability. We'll keep on studying more about Poisson processes in our upcoming lectures. Thank you.